In this segment, we will find the solution for 38b of this problem in page 92 from Siegel's biochemical calculations, same buffer as in part A. 0.02 molar phosphate buffer, 40 liters, 40 liters, 0.02 molar, and the pH of this buffer is a phosphate buffer, and the pH is 6.9. So we're going to refer now to part A of the problem in a separate video that we found the concentration of the H2PO4 minus to be 0.0134 molar, and the concentration of monohydrogen phosphate, HPO4 2 minus, being 0.0064 molar, 66 molar rather. Okay, so this is again, if you have questions about this one, go back and watch the video for 38A. So in B, we are asking to start with 0.8 molar phosphoric acid and the solid sodium hydroxide. So the first thing we have to do is to calculate then the volume of this phosphoric acid that we need, since we already know that we have a final the final volume of this, the number of moles that we are going to need in here. We have the molarity is number of moles by the volume in liter. We know the volume that we have is 40 liters, and we want to make a 0.02 molar solution. All phosphate comes from phosphoric acid. Therefore, we calculate the number of moles of phosphoric acid needed for this buffer. It's going to be 0.02 times 40. We already did that before, but I'm just repeating here, 0.8 moles of phosphoric acid are going to be needed. Our phosphoric acid this time is a 0.8 molar solution. So we need to calculate the volume that we need to get from this phosphoric acid the 0.8 moles that we need. So the volume is going to volume of phosphoric acid. It's going to be needed from this 0.8 molar solution. Is then calculating here by, we have the number of moles and we have the molarity. So the volume is then the number of moles, which is 0.8, divided by the molarity, which is also 0.8. So it's going to be a simple one, 0.8 for the number of moles, 0.8 for the molarity, 0.8 divided by 0.8 equals 1. So it's 1 liter of this solution. 1,000 milliliters, 1 liter of these solutions required to make this 40 liters of the phosphate buffer 0.02 molar that you want to prepare now. Now we need to deal with sodium hydroxide. Okay, let's move up a little bit here, get more space. So initially we are going to have only phosphoric acid, but that's not what we want in this buffer. We want in this buffer to have dihydrogen phosphate and the monohydrogen phosphate in equilibrium, right? So we have H2PO4 minus and the HPO4 2 minus in equilibrium with that space. Right? So first we have to pick up all the phosphoric acid that we have and then remove the first proton to remove H3PO4 of the picture, right? We have 0.8 moles of H3PO4. Therefore, we need 0.8 mole of sodium hydroxide to remove the first proton. Okay, that's just for this first step in here, for the first proton. Now we need also sodium hydroxide to remove from that one So we move from H2PO4 minus to generate HPO4 2 minus. We know how much HPO4 2 minus we need. You calculated that in part A of this problem. So we know that we need to have, for that buffer to be at that pH that we require, we need to have a concentration of HPO4 2 minus equals 0.0066 molar. If you don't know where this is coming from, go back and look at 38A, and that will be there. We need 40 liters, so number of moles of HPO4 2 minus that we need to generate are going to be 0.066 times 40, which gives 0.264. Similar exercise of A. Now we need a total number of moles that we need is 0.8 plus 0.264, right? One for the first step, another amount for the second step of the reaction. It's going to be 0.8.064. This gives a total of 1.064 mole, the total mole of the sodium hydroxide. Very similar to A, but now we have sodium hydroxide as a solid, not a solution. So we need to know how much grams of that I'm going to weight and put to make this buffer. So the mass is going to be the number of moles multiplied by molecular weight. Molecular weight of sodium hydroxide is 40. So it's going to be a mass of 42.6 grams of sodium hydroxide to make this buffer solution in the desired concentration. We just add 1 liter of phosphoric acid and 426 grams of NaOH and adjust the volume to 40 liters.